não, não. Aquela câmera.
Good morning. First of all, I'd like to say that I'm honored and very happy to introduce our note speaker. She is a dear friend, a person I like a lot. We are both members of the Ontology and Conceptual Modeling Research Group, NEMO, and as such, I have had the pleasure and the privilege of working with her. Renata is very enthusiastic. She's competent. She likes to collaborate. She brings great ideas, and she always raises questions and issues about the works that make us be inspired and instigated to investigate. She's a great person, as I said, a great friend, and she's a dedicated and important researcher for our community. In fact, she has been contributed to our community for many years and in many ways. For instance, she is member of the steering committee of Ontobras. And today she's here to talk about an important and very interesting subject. And I'm sure she has a lot of knowledge to share with us. I'll now follow the protocol and I read her short bio. Renata Guizzardi is an assistant professor at the Industrial Engineering and Business Information System Department of the University of Twente in the Netherlands. Moreover, she is a founder member of the Ontology and Conceptual Modeling Research Group, NEMO, and of the Laboratory of Supporting Technologies and Collaborative Networks, LabTar, at UFES, Brazil, where she has based from 2009 to 2016. For around 30 years, she has been busy with research work on computer-assisted education, requirements engineering, conceptual modeling, and ontologies, focusing on the interplay of these research areas to improve the development of information systems and organizational practices. Since 2021, she has been the steering committee chair of the Ibero-American Conference on Software Engineering, CIBSE, and she has also been part of the organization committee of many other conferences, such as IAR, SCIS, CAISE, and EDOC. She is also in the editorial board of the International Journal of Knowledge and Learning, and often serves as a reviewer for relevant scientific journals, such as the Springer Software and System Modeling and IOA Applied Ontology journals. Welcome, Renata. Thank you very much for accepting our invitation and for being here with us today.
Hi, everyone. Good morning. First of all, I'd like to thank both ICBO and Ontobras for the kind invitation. And it's really a pleasure to be here to share with you the results of our work. And this latest work focuses on ethics for technical systems, but particularly on AI systems. I think this is a very instigating topic, and I'm sure that many of you have news, and we've been also very following a science fiction talk about these issues for a while, and suddenly, because the impact of information systems gets higher every day, and especially we see AI systems being pervasive in our lives, ranging from diagnostics, but also making decisions regarding who can take a loan or not in financial institutions, or assisting education, health, airplanes, autonomous cars and weapons. I mean, it's a range of applications, and this has to also raise concerns for us, right? And we've been seeing both in the media and in the academic world, concerns that touch the ethic realm. So, for instance, can AI lead to job loss? Because since we have more and more automated tests and activities, and AI performing sometimes as well or better than humans in specific points, can this lead to job loss and health inequality, not health, economic inequality, social inequality? Also considering that not all countries in the world will have access or the same level of access to AI systems, right? We've heard of many cases in which bias occurs in decision making. I'm sure that some of you have heard of the famous case in Amazon that was using an AI-based system to hire, to bring new people in the company. And after using it for a while, they realized that the system was suggesting to hire men all the time, right? And why does this happen? I mean, it has to do with the quality of the data that is fed into the system. So if, for instance, there is much more data about men, and since the algorithms of AI sometimes are black boxes, then the AI concludes that men can be more competent, for instance. Okay, so it depends a lot on the data that you used and also on the algorithm, because of course algorithms are also made by biased humans, right? So there's this two risks there. How can we prevent this from happening, right? And there are today a lot of researchers busy with debiasing systems, right? But they also say sometimes it's very hard. And when you start tweaking the data to make it less biased, you may even lose power in delivering good results. So it's not a very straightforward solution, let's say, right? And in some cases, this can have drastic results. Like in the Netherlands, there is also a famous case in which the tax system was taxing much more people from lower income and typically immigrants coming into the country than in general. And this led even people to end their own lives because of this. So you can think of the absurdities caused by an information system, right? What else can we think about? I mean, many cases of rogue AI, right? So what if the artificial intelligence decides to do something as a result of the decision-making process that will harm us, right? And well, right at this point, we are far from the, let's say, situation in which AI has the power to have intentional actions that are against humans. This is a long way to go, but we know that maybe the biggest concern now is like how AI, in conjunction with bad decisions from human beings, can do us harm, right? So who has access also to this AI and what they can do with it? For instance, should we allow this to happen, and in which cases is this acceptable at all, if at all, right? And how about AI making mistakes, making big mistakes? How much impact can this cause in our lives? As a result of this, we've seen a lot of manifestos. So today, if you go to the internet, there is AI manifesto, ethical AI manifesto. In the past months, we've seen also some AI researchers and entrepreneurs signing a letter to stop, right, asking to stop the development or the speed of the development in generative AI, such as ChatGPT. However, my opinion is that we really cannot stop the development, right? Even if we think about how market works, a competitor will not, a company will not stop its development thinking that maybe the competitor will not stop and they will lose market. And there are other reasons, right? So how can we, as academics, as researchers, contribute to alleviate these problems, right? There are many, today there are many researchers talking about it and developing research and valuable research in this regard. So for instance, there is a group of people that have developed a framework for ethical AI. And this framework has been then used by the European Union in the Ethical Systems Act, right? There are, like Virginia Dignan, for instance, she's busy with responsible AI, and there are events organized around responsible AI, not only talking about ethics, but also sustainability and other important and related issues. Also standard bodies like ICBO, right? So process for, I cannot read there, but it's about ethical concerns during system design, right? So all this has been like bubbling in our community. A lot of interest has been raised also in research in this area. And I invite you all, if you would like to come work in this topic. It's let's say a niche, right? It's a possibility to develop very interesting things. And in ontologies, we can contribute a lot. I hope that this talk will motivate this claim. All right, so the European Union in April 2021 has created this ethical act, right? It's like a legal framework on AI. And this legal framework includes ethical concerns. So what does it mean for a system to be ethical? What kind of features you need to have in a system, or principles that guide the development of ethical systems, okay, or systems resulting in ethical, bringing about ethical results, right? And all this is very important. However, in order for us to actually develop systems that are ethical, the debate needs to go from the law and also from the theoretical principles into tools that system developers can use. Okay, I think that nobody will disagree with me when I say that, because everybody will agree that we want ethical systems. But how can we guarantee this will happen if the developers themselves are not aware of these and don't have practical tools that they can use in the development of the systems, right? So this is an important claim, right? So the theoretical debate is important, but even more is to create information systems engineering practices aiming at ethics by design. So we've been hearing, oh, security by design, privacy by design, why not ethics by design? So the work that you will, I will now present is basically described in this paper, in this journal paper that has come out very recently, in July 2023. So you can find more detailed information there, and I would be delighted to collaborate with you in this topic. All right, so first of all, we need to understand that this is a work aimed at to endow requirements analysts with a tool to develop ethical systems. We think that requirements engineering has a fundamental role in guaranteeing the development of ethical and trustworthy information systems. If we see the cycle of information system engineering, requirements engineering is right here, right? So it's in the beginning of the process, and it's concerned with the needs and the wants of stakeholders, and not only aiming at capturing this in the beginning, but even after the system is deployed, requirements engineering is there to help us analyze and monitor the requirements and see that if the system is running, the requirements are not changing. And so if it changes, we have to cope with it. So it's all about what are the intentions regarding the use of the system, and also the qualities. So what kind of what we call non-functional requirements do we have to guarantee the system follows? So for instance, non-functional requirements are like security, reliability. So what kind of non-functional requirements can be important also when we think about ethics, right? So for us to develop ethical systems, I believe that requirements and engineering is really crucial. And the idea then of our work is to promote a semantic understanding of the ethical principles that are considered beneficial for trustworthy systems, right? For that are like, should be the base of trustworthy systems, like beneficence, non-maleficence, autonomy, justice, and explicability. This is the result of the work made by the AI for People team, right? And proposing a requirements engineering methods that guides the analyst in capturing such ethicality requirements, right? So we convert these principles into the ethicality requirements, however, trying to go deep into the semantics of what these principles mean in reality. And so we want to guide the analyst by doing this semantic understanding, by granting the semantic understanding, we provide the analyst with the tool to use the ontological concepts in the elicitation and analysis of requirements. Okay. As a result, we propose a method or that is, let's say, it's an ontology-based requirements engineering method. We call it OBRE. And it's composed of 3 phases: semantic understanding of a given non-functional requirement. In this case, the ethicality requirements that I mentioned, beneficence and autonomy, justice, and so on. Then we may instantiate this ontology that comes from the phase before. And finally, we go into a requirements analysis phase. And in this phase, we may use different kinds of methods and techniques. This is the choice of the analyst of what he prefers. For instance, requirements table, user stories, or goal modeling. But this is very much assisted by the previous phases, the semantic unpacking of the concepts and the instantiation. So about the ethical principles, how do AI for People define these principles, right? Beneficence means do good, promoting well-being, preserving dignity, and sustaining the planet. This is beneficence. Non-maleficence, on the other hand, is do no harm, avoiding potentially negative consequences of overusing or misusing AI technologies. How do they see autonomy? Okay, to strike a balance between the decision-making power we retain for ourselves and that which we delegate to artificial agents. This is done in AI systems all the time. We defer the decisions to the system. And sometimes there are situations in which it's even beneficial that the system will reason that that situation is beyond their capability, so they should give back the power to the user. So this kind of thing is focused on autonomy. And explicability, making the AI decision-making process intelligible, so explicit, explained, and accountable. Who is responsible when something goes wrong? Okay, so all these are the principles that have been developed and now are part of this AI, Artificial Intelligence Systems Act, right? And our solution is based on analyzing all these principles ontologically. I guess many of you are really working on ontological analysis. And let's compare it with a kind of a tree, right? So these concepts that we want to understand, if we use foundational ontologies, which are domain agnostic ontologies that may provide real semantics to the concepts, and on top of it, other ontologies, domain ontologies, core ontologies that are founded on such foundational ontologies, we are more able to understand these concepts, right? So basically, we need to understand which of these core ontologies can help us understand the concepts and start relating them to provide such semantic meaning. And this is a very, let's say, good practice. I guess in our community, this is well known because it provides consistent semantics, right? And I guess what I mean to say is that reuse, and when we talk about having these core ontologies here as basis for new ontologies, we are talking about reuse. This is in the center of the work on ontologies. So our advice is that when you go, okay, I'm going to develop a new ontology, let's see what's out there. Let's see what exists that can help me base my new ontology on, instead of starting from scratch. If we do this, we are much more able to come up with a good and consistent ontology, provided that we have well-founded ontologies here, right? Because then a lot of people have already thought about these ontologies. This has been axiomatized, tested, and we don't incur in mistakes that we would if we would start thinking all over again. So in our work, we use UFO and the OntoUML language that is already capturing UFO concepts. And we use different core ontologies, for instance, the non-functional requirements ontology, the common ontology on value and risk, UFOL, which is on legal concepts, and decision-making, the decision-making ontology, DMONTO. All these ontologies have been chosen because it makes sense to use those concepts that they cover in the in understanding the principles that we are talking about, okay? So we're going to see excerpts of these ontologies throughout the talk. First of all, it is important to understand that ethicality requirements is a kind of non-functional or quality requirement, right? And this is the result of a work that we did previously, which understands the quality requirement as referring to a quality universal, and that instantiates a quality, and then each quality has a value in a quality region. So if we think about it, we can, if in terms of requirements, we can have a quality region being divided, being split into a region that of ethical systems and unethical systems, right? And in this paper here, we talk about how to deal with such kind of non-functional requirements in terms of constraining the requirements and being able to actually calculate how well we meet such requirements. And the principles that we will analyze, we start with beneficence and non-maleficence. They then are kinds of non-functional requirements, right? And an ethical requirement can be composed of several of these requirements. Start then with beneficence and non-maleficence. How do we see ontologically beneficence? Do good, promoting well-being, preserving dignity, and sustaining the planet. We see this as generating value to the stakeholder. Okay? And non-maleficence, do no harm, avoid the potentially negative consequences of overusing or misusing AI technologies, we see as preventing risk. So because of our understanding that beneficence is about generating value and non-maleficence is about preventing risk, we adopted the common ontology on value and risk as the basis of understanding what beneficence and non-maleficence are. This is a work by colleagues of ours, and the reference for the paper is there. So how can we then frame beneficence and non-maleficence as derived of value on one hand and risk on another? And basically, this has to do with two kinds of events that are covered in cover, that are focused in the cover ontology, right? One is a gain event, gain event, which is a kind of event that brings positive impacts to the intentions of an agent, or also a loss event, which negatively impacts the intention of the agent. This is modeled, then I can show you if you want during the question and answering parts, how this relates to other concepts in cover. But this is the one that we need to understand here now. And then we can say, just because it's easier to explain with this slide, right? So the user has an intention to accomplish a goal for which he or she relies on the system. The system has the intention to create a gain event, and a gain event is a type of event that positively impacts the agent's goals. So it's about the system having capabilities that are appropriate or that lead to the creation of gain events, of events that will affect positively a certain intention of the agent. In the non-maleficence requirement, on the other hand, the user has the same intention, an intention to accomplish another goal. The system has the intention to prevent a loss event. And a loss event is a type of event that negatively impacts the agent's goals. So this is about the system having vulnerabilities that although they are there, they do not exert an impact on the agent's intention. Okay, the system is able to prevent this to happen, that the vulnerabilities affect negatively the user. So this is the semantic understanding we have about beneficence and non-maleficence required. It is important to realize that for this kind of systems, there is a shift on how we think about the stakeholders of a system, right? The stakeholder is not only the end user. Let's say here is an autonomous car, and the end user is a passenger, okay? But there is a whole ecosystem in which the system is embedded, and you have to consider other stakeholders that are impacted by the use of that system. So for autonomous car, you not only need to comply with requirements from the passenger, but also from pedestrians, from bystander, from nearby cars, right? So for this kind of AI systems, they don't affect only the end user, they affect much more. So we need to care for all of these stakeholders. We call it an ecosystem of stakeholders. Then, okay, once we talked about the semantic understanding of the principles and of the kind of requirements, we can go ahead and instantiate the ontology. So here is two very simple cases of beneficence and non-maleficence requirements, right? One here, that the car should choose a quicker route towards a destination, because this is to make the intention driverless car arrives on time at the destination, and this intention intends to create driverless car arrives on time at destination and will fulfill an intention of the passenger, which is don't be late. On the other hand, the car should adopt a defense driving behavior to prevent aggressive direction. This is an intention of the system, right? A non-maleficence intention. That the passenger intends to prevent the passenger from feeling nervous in the car, and this would negatively impact feel safe if the passenger would feel nervous, right? So this is a way. Then how can we instantiate this? This depends on actively thinking of such situations. So that's how we are now guiding the requirements analysts in doing so. In order to, okay, if you say to him, come up with beneficence requirements, sometimes, too abstract. But if you think about, think about the intentions of the user and how this can be associated to gain events and loss events. So, and then you come up with such requirement based on this reasoning, right? In the end, what we have is this kind of guidelines that we also describe in our paper. Okay, so identify events, gain and loss events. Identify the stakeholders that participate on such events. Identify requirements to create gain events, prevent loss events. So it's a practical guideline to an analyst, a requirements analyst, based on the ontological approaches, ontological concepts. Okay. Much more concrete, right? So in the end, either if they choose a requirements table or a goal model to come up with the requirements of the system, they will have something like this. For instance, what we see here in black, in highlighted, right, in highlight mode, we see here all the concepts that come from the ontology, and then the analyst will think, okay, impact event, arrive on time at destination. This is a positive event. Then the ethical requirement is this. Oh, okay. The bystander. Be splashed if the car passes by a puddle of water. This is a negative impact event. Okay, so a non-maleficence requirement would be the car should slow down in case there is a puddle of water near the bystander. Okay. If you think about a more sophisticated approach, right? Here is an example of a GO model, I-STAR model. I'm not sure how much you know about this, but it's a very prominent framework on requiring goal-oriented requirements engineering. Here we model the actors of the scenario, the goals they have. So putting here beneficence and non-maleficence as goals, and refining these goals into requirements, and also dependencies, how they depend on each other, and in this case, on the system to accomplish these goals. If you look at all the marked concepts here, this can all come automatically from the instantiated ontology. So we can establish a kind of a mapping from the instantiated ontology to such kind of models and propose some kind of automation that will help the requirements analysts in modeling their requirements model, okay, their goal model. All right, so this would, let's say, it's a complete cycle of our ontology-based requirements engineering approach. First understanding the semantics, then instantiating the ontology, and finally coming up with the requirements model, okay? We've done this for beneficence and non-maleficence. And now we're going to see other kinds of like autonomy, explicability, other kinds of ethical requirements. And before we do so, we're going to talk about ethical conflict. Okay? This is an important thing because it is bound to happen, right? And we as humans, we are able to deal with such ethical conflicts in our everyday lives. So if you think about a doctor working in a hospital, okay, they need to okay, in face of limited resources, suppose that there is only one bed and 2 sick people, they need to find some criteria to select which is the person taking the bed. Okay, maybe the one more risky, with more risky kind of needing treatment more urgently. So we make these kinds of decisions every day. And systems, if we put them in our lives in a pervasive way, making decisions on our behalf, they need sometimes to face such dilemmas. So we need to endow them with possibilities of dealing with such conflicts. Let me show you an example, still using the driverless car, right? Suppose that the agent, as we said, has an intention, the passenger has an intention to be safe, right? So there is a requirement saying that the car should keep the passenger safe. Imagine now that the car should suppose that the passenger that wants to be safe is in a situation, in a risk experience, what we call risk experience, right? So it's an event composed of several risk events that can be loss or gain. Suppose there are other stakeholders that are also participating in this risk experience. A typical case, a car is driving autonomously and there is a situation in which either the car needs to choose to hit the tree and harm the passenger or run over, I don't know, 3 pedestrians. What should the car choose? Okay. This is a tough one. It's a well-known problem in philosophy called the trolley problem, right? What should the car do? Then this is what's happening. Both the passenger and the pedestrian, they participate on the same risk experience, which is dodging a tree, right? Okay. In this case, the car decided to run over the pedestrian, which will hurt the pedestrians, and save the passenger. This is one possibility. The other possibility is that the car will save the pedestrian and harm the passenger, right? So the idea here is not to provide a decision, because this is, I guess, a matter of what ethical framework you choose to base your decision, but to raise the awareness of such kind of conflicts. Okay, so for the analysts, it is important that they look for such types of such instances of conflicts related to their system, right? And provide some kind of solution, right? I guess if you think about the owner of the cars, of the company producing the car, this would be the kind of solution they would prefer, to keep their passengers safe. But is this the best solution? We have to think about it. We have to be aware and solve such conflicts. It is not acceptable that we release such system without thinking about those possibilities, right? So our idea to detect ethical conflict is that for each stakeholder, consider possible events, namely risk experiences that meet these stakeholders' requirements, fulfill her intentions, and lead to loss events to each of the remaining stakeholders in the ecosystem. So we have to consider from one stakeholder what kind of risk experience you might have involving all the other stakeholders in the ecosystem, and try to come up with solutions that will resolve the conflict, right? All right. Now it's the time to reason about autonomy requirements. As we said, there are 4 principles we deal here in this talk: non-maleficence, beneficence, autonomy, and explicability. And there is in the literature a lot of talk about autonomy. It's not new. It's coming from old AI systems, also from the multi-agent systems community. Talk about autonomy, right? Autonomy is one of the characteristics of an agent in multi-agent systems. And we can summarize these views as, okay, autonomy is the capability to decide without human intervention. Then there is a stronger claim, capability to act without human intervention. Okay, I want my system to decide, but then provide the decision and the human can choose. Oh no, my system can decide and act also on behalf of the user without asking the permission or the let's say the opinion of the user. And the ability to know when it should decide or act on behalf of the stakeholder or not. So this is even more advanced, because here the system has the knowledge to assume that, okay, in some cases I should decide and act on behalf of the user. In some cases I should defer this possibility for the user itself and say, okay, in this case I don't know what to do. And depending on the system, this can be very various, right? There are some systems like surgery, the robots performing surgery, that they might want to give much more power to the user than deciding on themselves. Now, systems that are doing things that are not so harmful, right, may have more autonomy to decide and to act. So it depends on the application. But it is our intention with our ontology to capture these 3, at least these 3 possibilities, right? And I will not go through in detail about the ontology, but I must say that the main concepts here are delegation. This is a concept that In UFO, we've analyzed since early ages. So what does it mean for one agent to delegate something to another, to delegate an intention to another agent, for instance, right? Because if you think about autonomy, this is what we're doing. How much does the user want to delegate to the system, right? And there are different levels of autonomy, right, to capture the aforementioned notions. And also, there is the concept of social position, and this part here comes from UFO-L, right, legal ontology based on UFO, and that talks about rights and responsibilities, right? So like rights and duties, permission and no rights, disability and immunity, and power and subjection. So these are like in UFO-L were like analyzed as legal positions. Here we are talking more as a contract between the user and the system. So it's a social position in which we establish such, let's say, such positions as a contract between them, so that the user, the system knows what to do, right? And that we are sure that it meets such such duties and rights and so on and so forth. Key definitions here are always start from the intention of the agent, right? So the stakeholder of the system has intentions, which are mental properties related to goals. The stakeholders may have the intention to have a system that acts autonomously for particular functionalities leading to autonomy requirements. The stakeholder may delegate to the agent to take specific decision on her behalf. This delegation has a level of autonomy, low, medium, high, for instance, and the delegation aggregates a number of social positions. So these are the key definitions of our autonomy ontology. One guideline that we can extract from it is focusing on the social position. For example, the system has duties, permissions, disability, immunity, power, right? Duties, I think everybody understands, right? So you have the duty to do something to someone. Perhaps it's easier to say, to give examples here. So, for instance, the system has a duty, the driver's car has the duty to follow laws, traffic laws, while conducting the passenger, right? A permission is something that the user can, the system may do on behalf of the user. So the driver's car has the permission to calculate the best route unless the passenger explicitly requests to do so. A disability is something that the system cannot do. So let's say if there is a permission on one side, there is a disability on the other, right? So the driver's car cannot change destination without the explicit request of the passenger. And power means having the power to decide, right? So this is also important when you think about those situations in which the control needs to be deferred to the user. In this case, here we model, the driverless car has the power to decide the best course of action in the imminence of an accident. This could be, I mean, we can argue if this is the best approach, right? We could have done, okay, in case of a risky situation of an accident, imminent accident, if it happens with a certain flexibility in terms of time so that the user can react, this car should defer back the control, give back the control to the user of the system, to the passenger in this case. Right. Going back here, so this is one of the guidelines. Also important, when we think about correlative social positions, sometimes it makes our lives easier. For instance, The pedestrian has the right to cross the street at red lights. This is something that is even in the traffic law, right? Consequently, the driverless car has the duty to stop at the red traffic lights. Okay. So if we think about, if we see the social positions, they have these pairs, right? Duty from one of the stakeholders means the right of another stakeholder. Permission means that the other has a no right to block that action that is permitted, and so on and so forth. So thinking about these pairs of social positions can help. And also capturing this risk experience in which the system must defer control to the user. So again, if we think about our example of the conflict, ethical conflict, right? When there is a risk experience, there might be a good solution to give control to the user. This is one possibility in that case. All right. Now moving to explicability. How are we with time, Mona? 10 minutes? Okay, it's gonna be fine. So explicability requirements. All right, so reminding you of what we said before, explicability is about making explicit, intelligible to the users, to the stakeholders, the decisions from the system, right? And holding them accountable, holding the person that is responsible for that accountable in case something goes wrong. For modeling that, we use the decision making ontology, Diamonto, which is a previous work that we've done, because we need to account for the decision and action cycle of the system in order to provide such explicability. For instance, there is a decision, the system takes a decision based on what we call valuation. This comes from the value ontology, which is already reused in the decision-making ontology of different options. So different options are valued, right? And based on the preference, on some preference and on some criteria, a decision is taken. So here we highlight that the evaluations are based in different criteria. And these criteria, they are qualities and dispositions related to the different options, okay? So even if we think about simple decisions, to give you just an example, when we decide which movie we want to watch, we have the characteristics of the movies, right? Maybe we want a shorter one, we have a short time to watch a movie, or so these are qualities and the intentions that we have. So we want to watch something for half an hour. So time has to be taken into account, right? The criteria has to do with this thing. So the decision is taken by the system based on the evaluations, and the evaluations based on criteria. And the system then takes a decision resulting action. So the action itself based on such decision. As you can realize, decision for us is mental. It's a mental aspect. It's not the action itself, because some see the decision as an action. But in our approach, decision is an intention already. So it's something that is in the mind of the agent, and then we have to act on that decision, right? Because between deciding and acting, many things can happen as well, right? So thinking about the system in this having such decision and action cycle, explicability requirement is the ability that we have to making a trail of provenance explicit, right? So tracing the decision-making process. So this decision, so the action that the system did, because this is what we see, realize the result of the system is that, okay? this action comes from which decision? What was the deliberation and the criteria used for such decision? If we want systems that are explicable, you need to trace such process. And then this generates for us some guidelines as well. So trace the decision-making process from the actions that go against stakeholders' intentions. Why do we say go against? Because these are typical actions that we want to explain, right? So if the user wants to understand, why did you deviate? We were going this direction, it was the quicker route, why did you deviate? Oh, then the card says, oh, there is a construction in the roads, so we cannot go on. Or there is a traffic jam in this route, so I deviated. Okay? And trace the decision-making process for actions taken as a result of deliberation to overcome risk events. This is also important. So if you have a risk event, you want to understand what was the reasoning behind the decision of the system, right? So these are two guidelines I'm exemplifying here, but we can think of other guidelines. You can see that guidelines, they are based on the ontological concepts, actions, risk events. So this is how the ontology is enabling the use of the requirements analysis, okay? So from a very abstract principle, we generate, we understand it in terms of concepts that are more concrete, and then we create such guidelines based on the concepts to give this tool to the analyst. Here is an instantiation regarding explicability, right? So again, there is that step of instantiation in which we think about cases, and then here in this case, we are thinking about decision, we are thinking about the preferences regarding specific choices, and we can come up with the explicability requirements. And here, some examples. So the driverless car should explain why a particular route was taken to conduct the passenger to the selected destination. The driverless car should explain why changing route in the middle of a ride, and so on and so forth. So there are some examples there. And since we still have some time, I didn't have a slide about it, but it's important also to talk about the accountability part of the explicability requirement. And how do we think that we can help with that, with our ontology? Going back to the social positions that we took on the autonomy, from the autonomy ontology. Because if we have there duties established between the system and the user, then if this duty is not met, it's not fulfilled, we need to have who's accountable for that. This is not an easy, let's say, reflection to do or easy solution. There is no easy solution, because you may think, okay, in case of an algorithm, an AI algorithm, if it goes wrong, who's responsible? Is it the programmer? Is it the owner of the company selling? And even we've seen that these sometimes they go to the courts to decide, right? Because case by case can be considered a different solution for this problem of accountability. And there is a particular, this is also a particular area of research. There are researchers investigating accountability. Who should be accountable, right? But at least we believe that the ontology that we propose has the concepts that allow you to model this, okay? So duties should be fulfilled, should be met. If they are not, then you have to think of who is accountable for each of those duties, right? Okay, so now we move to the conclusion of our talk. Just to summarize and have some general takeaway messages. The information systems are more and more pervasive. We have a huge influence in our lives. We have to be aware of that. And we have to think of that as an opportunity in one hand, because there are wondrous things that can be done with systems. But also this brings risks and brings ethical conflicts and claims that we can make, right? The discussion about ethical principles is very relevant in life, right? And there are a lot of people busy with such discussion. Besides defining such principles, it is very, very important to propose information systems engineering practices that enforce such principles in practice. Okay? And here, note that we go so far as providing something that the requirements analyst needs to think. Who is it to say that when the system is coded, this is respected? So our work is not finished, right? But starting from requirements engineering is a good point, because this is the discipline that is concerned with the needs and the wants, the intentions of use of the system, right? Both in terms of functional and non-functional requirements. And ontologies, so both requirements engineering and ontologies should play a big role in the development of ethical information systems. And the role of ontology here is on semantically understanding what you need to do. But also, if you think about how ontologies can help with the explanation of the systems, this is something that we should take into account, because many of these AI systems are based on quantitative approaches, right? And like machine learning, they look for patterns, but they don't have semantics. The data doesn't have semantics. So how can you explain how what path the system took if the system doesn't really understand what the data means? So if you think about ontologies also in this sense, right? So you need to have some kind of explicit model or understanding of the data in order to provide constructive explanations, okay? How can ontology-based requirements engineering contribute, right? So in our case, may guide the information system analyst in capturing ethicality requirements by instantiating ontological concepts dealing with ethicality. So far, we have analyzed these principles. In the AI for people, they also have the principle of justice. So there is more to come also on this. It supports capturing ethical conflicts between different stakeholders by anticipating conflicting events. So the idea is not taking a particular ethical stance, but to provide the right concepts to guide the analyst in analyzing the conflict. So first of all, becoming aware that these conflicts exist, right? And then having to think of a solution for that. We've also thought that our next steps could be like thinking about different frameworks on ethical frameworks, how to analyze these conflicts, taking different ethical frameworks and then kind of plugging in different ethical frameworks using the same concepts that we have started with. Okay, so this is it. Thanks a lot. And I'm looking forward to your questions and comments. Portuguese as you prefer.
Close to the microphone, please.
Cesar, and then Flavio.
So basically, we developed these AI systems because we want the systems to behave like humans. And now we have to define ethical requirements because we don't want systems to behave like humans ethically, like to avoid them being sexist and racist. And I would like to go back to your Amazon HR case where the system was understood that it was acting in a sexist. And I assume that it was because it was trained on sexist data that was produced because of sexist human behavior.
Yes.
How could you extrapolate your framework also to the data that is collected because of our bad behavior? Because I would say that this is, even if you define ethical requirements, the system will not be able to act in a different way because it was trained on unethical data.
Yeah.
Thank you.
So, in fact, our approach, it goes up to the abstract level, right? So you have the requirement, okay, you want the system, this kind of systems, you have to think, okay, you need to be fair depending on gender, independent of gender or color, right? This is the requirement, let's say. And then it is the role of the developer of the system in order to cope with such requirement, to take care of the data. So you need to make sure that the data is not sexist in the end, right? So there is the point, I guess our work is more on making the harm or the risks aware so that something is made in terms of how the system is evaluated, right? In the paper, we show that when we compared the case study that we did on autonomous car with another existing report on requirements for autonomous car, and we see that in the requirements there is nothing about the ethical behavior of the car, right? And when we go with this frame of mind, then we think about the ethical challenges. So this is the point, but we are not, as you said, I mean, for us to, we cannot really enforce this to happen if the developers don't care for meeting the requirements.
Hi, Renata. Thank you for the great presentation. Actually, should say that because I'm your colleague as well, but I mean, it's always a pleasure to hear you talk about your research. Always very exciting. Could you be so kind as to return to the table on autonomy?
Okay.
Okay. So the thing is, the impression that I have from your presentation is that you are applying your research to the domain of artificial intelligence applications. But the question is much more profound than artificial intelligence. And when I look at this table, I get the impression that the ontology, the part that is really about artificial intelligent agents, is a thin layer of the whole thing, which talks about the autonomy. And not only autonomy, but autonomy of non-deterministic systems. All of these things seem to be issues of delegation. You could talk about these things in terms of people who have autonomy to engage in actions and events in a process. And I know that there would be a whole different literature to be considered if we go to that level, but I think that for me, I would be interested in seeing this in the classification of process and automation of process through deterministic and non-deterministic systems. Because when you talk about non-deterministic ones, we are more interested to how to blame people when things go wrong.
Yeah.
And did you consider that as a possibility already? follow up that second question.
Well, actually, when we thought about the ethicality requirements, we thought not only with respect to AI, but any kind of complex system like social technical systems, which can also involve the work of humans, right, in the middle. So it's a combination of what is automated and what's not. So in this sense, yes, we consider processes as well. But in this sense, so how can we prevent systems in general to act unethically, right? So this was our focus from the beginning. And of course, AI systems are very much in focus right now. And because there is this autonomy among the principles and also the explicability, because for systems that are non-AI, it's easier to find explanations on the code, on how the system is done. And in AI systems, you really need to know how the decisions came, right? So this makes it specifically appropriate for AI. But other than systems, let's say we haven't thought. But it is an interesting
one other thing that I'd love to see in this regard is we are not, many of us are not trained for specific ethical concerns when you are developing a solution to applications. So having an ontology domain, even a catalog of stakeholders and recurring ethical requirements to inform and to enlighten the people work on this to come up with other ones. And also, even for organizations, I can see that for some requirements and for some stakeholders, they may not allow them their departments to develop systems that give autonomy to applications.
True.
So I can see both the utility for a catalog for these things, for recurrent requirements and stakeholders, and for within organizations, profiles of what can be automated and what cannot.
Yeah, true. And I think this is very important when you think about ethics, right? So what kind of decision do we want the system to have, to take, right? And so I guess our work is really like trying to indulge people that are involved with the development of the system. So not only requirements analysts that are the main focus, I mean, but also companies to understand, because I think it's a fact that we are not trained on ethics, right? But it becomes more important every day.
Thank you very much.
Thank you, Claudine.
Thank you, Renata, for bringing this very interesting topic. I have two more philosophical questions. The first one, do you believe ChatGPT is ethical? The second one is that I believe that people that will develop AIs that will affect us are today in graduate courses. And are you addressing this topic in your classes? How do you see this subject in our curricula in European scenario and Brazilian scenario? Because I have students in the beginning of information system courses, and when I try to bring this topic, most of the time they think that the accountability of the responsibility of the decisions made, if the system is ethical or it's not, it's from the owner of the company, it's who is putting the money in the system. So today for me, it's like a therapy now for me. It's very hard to bring this topic because it's not easy. Even today when they use ChatGPT, it's everything okay. In the beginning, it was a sexist tool, but it was okay because it's just a mistake. And I would like to hear from you about this.
Yeah, very interesting questions. Thank you. So I guess the point is with every technology, the use we make of the systems sometimes is not the system itself, but the use we make makes it ethical or unethical, right? So if you're, for instance, if your teacher asks you for an assignment and you go to ChatGPT, make the assignment for me, that's a very unethical use of ChatGPT, right? And I guess they need to be more explicit, I think, on how the system works. I think this is not there, although there are disclaimers, people tend to overlook such disclaimers, and a system that invents facts, as ChatGPT, should be transparent, because we know that, okay, it's mainly based on keywords and quantitative approaches that put these keywords together and find the correlations. So it's statistical algorithms. So it's very easy that you ask something, it comes from a very elaborate response that it seems true and it's not true. Right? There are wrong facts there. So I think that, I mean, we started using this and people are using sometimes very indiscriminately without having such awareness. And I think we need to be made aware of these things. And if you ask ChatGPT, it will respond truthfully that sometimes it invents facts, right? But is this known? So this is the reflection, right? How to make transparent to the user what the system does and why such things happen, right? Why? What is the system committed to do? What is not, right? And I guess this is the concern about ChatGPT and all systems that work based on it and so on and so forth, because it's being not only adopted by the end user, but by many organizations to base their own systems on top of ChatGPT. And regarding the discussion of ethics in the classroom, I think it's very important, right? And there are some topics and some courses that, for instance, at UFIS, I know that there is a course on computer and society. So this is a kind of a topic that will come up in this kind of course. And it is important to have such courses in the let's say in the curriculum, right? And I can understand that people overlook this and that this doesn't seem so important to them. And I guess it is our role as academics to educate ourselves on the ethics. Also, there is a whole science on ethics of technology. For instance, in 20, there is a department on ethics of technology. And so we need to educate ourselves to think of ways to convey such information, and to maybe a good way to do it with teenagers, that's usually our public, is, or youngsters, is to provoke them, right? So to tell them these cases. There are many anecdotes that you can think of, systems like this that incur in biases or mistakes that affect people, and that can serve as illustrations for our classes. But you should keep going. Yes, Mattia.
Thank you so much for the really great talk. I have a question. I really appreciated you bringing up the trolley paradox. In the trolley paradox, people always die, right? I mean, the opposite.
Yes.
But I'm wondering, and we discussed a little bit about that in the context of AI and highly complex systems yesterday when Barry gave his talk. Mm-hmm. It seems to me that we have sometimes ethical things that differ based on the context, right? Like driving over a red light is not a good thing, right? So no. Driving over a red light, if you are making room for an ambulance, is a good thing. Mm-hmm. Like similarly, in Germany, and I think in the US it's the same. If you are in front of a red light and there's a policeman who waves you to go through, the policeman overrides the red light. So I'm wondering, especially since we're doing ontology anyway, have you thought about maybe providing a taxonomy of, you know, I know that's an uncomfortable issue, but a taxonomy of the ethical requirements, right? So driving over a red light is not good, but killing someone is way, way worse.
Yes.
And then we see that sometimes in the context, this changes how we assess the situation. So driving over a red light might be admissible in some very small subset of cases where the context requires this. I just want to hear what you thought about that.
Well, actually, it is a great idea. I haven't thought about creating such taxonomy. In fact, so far in our work, coming up with the requirements is really still the work of the analysts, right? So what we are providing is like guidelines in terms of which concepts should be in the mind of the requirements when coming up with such requirement instances, right? So but these nuances need to be thought for each system. So for instance, for autonomous car, I guess it would be very beneficial to have such taxonomies and to reason about different ethical conflicts in this case, I guess, right? So it comes from conflicts like, should I cross the red light? So should I disobey a law? But because there is a bigger intention here, a bigger concern for a fellow passenger, for a fellow human, right? So I guess this would be very interesting as a follow-up. I guess we could use such ontologies to create this taxonomy. Thank you.
So thanks for the talk. I think it was a really inspiring example of applied ontology. I guess what I'm thinking about is regulatory frameworks and requirements, because it's one thing to provide a methodology for requirements engineering for those who are doing the work, but how is a company that has a profit motive, right, to become invested in implementing this kind of methodology when it may be against the interest of purely a profit motive? So what are the kind of regulatory frameworks? How does a methodology like this become institutionalized, or how do we educate decision makers at the government level to adopt and implement and incentivize methodologies like this?
Yeah, very good point. I mean, even in requirements engineering, there are some methodologies that already take the law into account, right? And so they are specific requirements methodology for legal concerns, for accounting for legal frameworks and so on. So I guess we could try to combine, right? So use such concepts for the coming up with the requirements, but using these specific methodologies that also take laws into account to make this more enforceable for organizations. This is an interesting idea. So instead of using goal models, you use something like normals, right? So pure I star, or no, we can use something like normals, which still already take like a part of the language is dealing with specific laws and specific issues within the law, and so on and so forth. And I guess I've heard a lot of talks lately. For instance, I've heard a guy that worked on a company, on a automotive company, so creating cars and creating autonomous cars, including. They said that, okay, what they do is go up to this point. So they don't go right? So I guess this is the point, right? So at the same time as we have methods, we need to try to motivate the lawmakers to consider ethics in a broader way. And I guess the European community was the first one that created some kind of act that is concerned with ethical systems, right? And I think that's a good initiative there. So we need to account for both.
Thank you.
Okay.
Yeah. So I thank you so much I really enjoyed your talk. So what I'm asking is just since you are exposed to different industries and in this very important topic, and I heard a lot about the driverless cars use case. So have you heard anything with AI and ethics that is in the biomedical domain or industry or finance? If you have those exposure, can you share? Thank you.
Okay, thank you for your question. Actually, one with the law that are enforced right now to so if it's in the law, they will comply, right? But I haven't heard specifically about any industry adopting actually an ethical framework in the development of the system, right? But when you talk about health, is a community that naturally is already much more prone to thinking about ethics than other communities like finance or I don't know, entertainment or things like that. So because the doctors, they are already facing many of these issues in their daily lives, right? And also the way they treat the patients and the privacy and all this seems to be an awareness that is higher in this community than in others. But not that there is a methodology that is applied on the development of the system. This I have not heard yet in any industry. That's why I think it's an emerging field for us to work in. Our last question.
Renata, parabéns pela apresentação. Vou fazer em português a pergunta, peço que você resuma em inglês para que. O ponto é o seguinte: esse último requisito aqui, eu estou achando que está subespecificado, ainda mais porque estamos falando de ética, né? Então, está dando muito poder para o agente autônomo. Em casos do direito, a gente vê que a engenharia de requisitos de questões de competência é muito baseada em regras. Em casos difíceis no direito, as regras não são suficientes. Você tem que considerar princípios e tem que considerar objetivos, policies. Então, a minha pergunta é, por exemplo, eu acho que voltaria aqui a dizer que, nesse quarto requisito, que a preservação da vida é mais importante que a preservação do patrimônio. E aí eu poderia dirigir meu carro para uma Ferrari, bater na Ferrari, ao invés de atropelar uma pessoa. Então, eu acho que está dando muita autonomia e precisaria trabalhar mais questões que teriam que ser avaliadas no caso concreto.
Com certeza.
Eu não consigo prever todas as situações por meio de regras. Então, seria a inclusão de policies e princípios nesse processo de especificação de requisitos éticos.
Muito bom. So just to translate what Ron was saying, is that we need more than only the requirements as they are now, like the less requirements specifically. This is too much power to the system, right? But some kind of principle that should be embedded in the car to say, okay, actually human life and preserving human life is more important than preserving property. So in the face of hitting a car, another car, or hitting a human being, it's better to hit another car that is stopped, for instance, right? That is parked. So I think that this is indeed a very general and requirement, and that we need to think more, right? So in which cases we need to we let the car decide, and in that decision, what needs to be taken into account, right? So in this case, it is underspecified, this particular, and it's just used here as an example of the power, but I should have thought of a better example, right? So it is important that in some ways and I guess this is what's missing in our work, I mean, is to, now that we have the general concepts that talk about, that help you understand what ethics, what ethical conflicts you may have, what ethical aspects the system touches, we also need now to kind of, so let's take bioethics as a framework, right? Bioethics is one that will always account for the humans and or for the also animals, right? Instead of property, right? So let's take this framework. Shall we couple now this in order to think of more deeper on the ethics, right? Because right now we are living to in the end, you need ethical analysts to come up with the concepts. Okay? So our work goes as far as, okay, this is how you think about these principles, but you need to perhaps have a plug-in, something that you can raise now attention for particular ethical frameworks that should be considered together here. Right? So we've been thinking about this, that, okay, even in the conflict, who decides, right? Well, what's the best, the trolley problem, what's the best? There is no, as Matthias said, I mean, there is no good outcome, but in fact, in life is like this. If the doctor decides who takes the bed, who doesn't, maybe one will die. But we need to be facing these conflicts. How do we make systems powerful enough to face these concepts, these conflicts? It's a difficult one, huh? Thanks a lot, guys.